Let's keep solving quadratics a lot like we were before. First, let's FOIL these two binomials. When we do first, we'll have 2x squared. Outsides give us 2x. Insides, negative 3 times x is negative 3x. And last, give us just negative 3. Combining the terms in the middle, we simplify this down to 2x squared minus x minus 3. And some things about this product that were different than last time is, first of all, we have a leading coefficient here. Now we have a 2 in front. And that's going to make factoring a little bit more difficult, but it also means that when we made this middle term, this negative 1, it's not just going to come from adding factors of that 3 now. We're really going to have to guess and test things. We still have a couple of those two special products, the difference of two squares. That's going to simplify just like it did before, where we square the first thing. 3x times 3x is going to be 9x squared. And then square the last thing. 5 plus 5 times minus 5 will give us negative 25. So we'll have that difference, meaning minus in the middle, but the two squares, the first thing and the last thing, are both squares. And we could have a perfect square situation again, just like before. Remember, we can't distribute the 2. That's ridiculous. What we need to do is square the first thing, square the last thing, but that middle term is going to be double the product of these two. So multiply them two together. 2x times negative 7 gives us negative 14x. Now double it. And that'll give us the middle term of negative 28x. Oops, I forgot to square that guy. So when we factor, it's really we're gonna have to rely on this guessing and testing method to help us out. But we can be thoughtful about it. Like, first of all, the first term comes from factoring 5x squared. Well, 5x squared is either going to be x and 5x, or it's going to be 5x and x. So that's the only, since 5 is prime, that's the only way we can factor this, is into x and 5x. The second terms for each of these binomials is going to come from the factors of 6. And the factors of 6 are either 1 and 6 or 2 and 3. And when we look at 1 and 6, that doesn't make 17, and 2 and 3 doesn't make 17 either. But remember, that's not what we're doing here. We really need to guess and test. So let's take that 1 and 6 and plug it in. Now test. Test the outsides. That'll give us 6x. Test the insides. That gives us 5x. Now, does 5x and 6x make 17? No, they don't. Now, that doesn't mean just scrap them and say that we're done. What we need to do now is switch them around into 6 and 1, because that will give us a different sum for these numbers as well. So the outsides, 1 times x is 1x, and 6 times 5x is 30x. Well, 30x and 1x does not make 17 either. So now we know that 1 and 6 does not work. So, back to the drawing board. This time let's do it with 2 and 3. The outsides will give us 3x, and the insides will give us 10x. That doesn't make 17. So, switch them around. 3 and 2. Now when we look, we'll get 2x on the outside, 15x on the inside. That does make negative 17 if they're both negative. So there's our factors, x minus 3 and 5x minus 2. Let's do it again for practice. When we factor this, 3x squared can only be x and 3x. And that 7 is just 1 and 7, because that's prime 2. So we just plug it in, 1 and 7. On the outsides, that'll give us 7x. On the insides, that gives us 3x. That's not enough to be 20. So switch them around. Put 7 over here and a 1 over here. On the outsides, that'll give us 1x, and on the insides, that gives us 21x. That can be 20 if we have positive 21 and negative 1. We still have our two special products, the difference of two squares. So, take the square root of the first thing, 2x and 2x. And the square root of the last thing, 9 and 9. One of them's positive, one of them's negative. If we have a perfect square, then we just take the square root of the first thing, 2x, and the square root of the last thing, 5, and square. Then we're done. If now, finally, solving the quadratic equation, we're going to do them the same way using that zero product property, where we have to factor this first and then set each factor equal to 0. So first, factoring 3x squared plus 10x minus 8 factors into 3x and x. And then we guess and test for that 8. It's either 1 and 8 or 2 and 4. And we want to make 10. Well, we could try 1 and 8. That'll give us 24 and 1. That doesn't make 10. So switch them around into 8 and 1. And that'll give us 3 and 8, which makes 11. Close to 10, but it's not 10. So that means that 1 and 8 are not going to work. So let's try 2 and 4. Outsides gives us 12, insides give us 2. Now that might work. If we want to make a 10 with that, we're going to need a positive 12 and a negative 2, and that'll make 10x. Now that it's factored, set each factor equal to 0. So this means 3x equals 2, or x equals 2/3. Or, just subtract 4 from both sides, x equals negative 4. And there's our two solutions. If we have the difference of two squares, factor it into 3x plus 11, 3x minus 11. Now we set each factor equal to 0. And solve. This is going to be 3x equals negative 11, which is x equals negative 11/3. Or add 11 to both sides and divide by 3, x will equal positive 11/3. Finally, what if it doesn't equal 0? We'll get it to equal 0. So subtract 4x. And we'll also add 5. That's how we'll get 0 over there. So we'll have 5x squared minus 20x plus 20 equals 0. Factor it, 5x and x, and then we got to factor 20. So that's either 1 and 20, 2 and 10, or 4 and 5. That's a 5. We can try 1 and 20 first. That'll give us 101. That's not going to make negative 20. So we switch them around, 20 and 1. That'd be 20x and 5x, which also doesn't make 20. So 1 and 20 is not going to work. Try 2 and 10. 50 and 2. That doesn't make it. So we switch them around into 10 and 2. That'll give us 10x and 10x. Well, that'll make negative 20. We need negative 20 with negative 10x and negative 10x. So we're good. Set each of them equal to 0. This would be 5x equals 10, so x equals 2. Or add 2 to both sides, x equals 2. So we end up with the same answer. X equals 2 is our solution. It's kind of interesting that we got the same solution. That means that we had a perfect square here. And we can take a closer look at this. Let's take a look at it from having the 5x squared minus 20x plus 20 equals 0 line. And what I notice is that each of these three terms is a multiple of 5. So what we can do is divide this entire side by 5. We'll actually end up dividing both sides of the equation by 5. But when we do that, we'll have x squared. And the negative 20x divided by 5 is negative 4x. And 20 divided by 5 is 4. On the other hand, 0 divided by 5 is still 0. That's a perfect square. X minus 2 squared equals 0. And that's why we have only one unique factor that's going to equal 0, and we end up with x equals 2.